Good afternoon, dear students. Today we are going to start a new chapter. The name of the chapter is Amines. So, today we want to study the carbon compound or organic compound containing the functional group which have the nitrogen atom instead of the oxygen atom. Till now, whatever we have studied about the those functional group which have oxygen present in them in the functional group. But today we want to study about the functional group that has nitrogen present in it, and that is these are the compounds we call them as amines. So the functional group may be NH2 or it may be NHR. This number of R can be increased or decreased in these cases. So let us start study about the amines. The chief commercial use of amine is as intermediates in the synthesis of medicines and fibers. So this is what it represents the importance of amines in our industrial purposes. These amines are majorly used as an intermediates or they are used in the production of the medicines and fibers. Amines constitute an important class of organic compounds derived by replacing one or more hydrogen atoms of ammonia molecule by alkyl or aryl groups. Let me explain this to you. Suppose you have ammonia, that is your NH3. Now, this NH3 has got three hydrogen. This is one, this is two, this is three. Suppose this hydrogen is being replaced by CH3 group, then it turns out to be CH3NH2. Or if it is replaced by C6H5 group, then it turns out to be C6H5NH2. This is what it is known as aniline. This is what it is known as methylamine, and these are the examples of amines that we are going to study. So amines can be produced by replacing one or more hydrogen that are present into the ammonia by the alkyl group or aryl group. So this is the definition of amines. Once again, amines constitute an important class of organic compound derived by replacing one or more hydrogen atoms of ammonia molecule by the alkyl or aryl groups. In nature, they occur among proteins, vitamins, alkaloids, and hormones. Alkaloids are those compounds which generally affect our nervous system, like nicotine or codeine or morphine. These all are known as the alkaloids. We are very much aware of about the hormones. We know the various types of vitamins, and we have even heard about proteins that we are going to study into the next chapter too, which is known as the biomolecule. Synthetic examples includes the polymers, dyestuffs, and drugs. As we have discussed, these amines are used into the preparation of polymers, dyes, and drugs. Two biologically active compounds, namely adrenaline and ephedrine, both contain the secondary amino group and are used to increase the blood pressure. So these are the hormones or the biologically active compounds. Adrenaline and ephedrine are, or they also have amine group present in them, which is the secondary amine. Novocaine, a synthetic amino compound, is used as an anesthetic into the dentistry. Dentistry means in the operations or in the treatment of teeth. That is what it is known as the dentistry. Benadryl. a well-known antihistamine. Antihistamines are generally used for anti-allergic, or they are used for the treatment of the cold and cough. So, Benadryl, a well-known antihistamine drug, also contain a tertiary amino group. So, in Benadryl, we have the tertiary amino group. Then it comes to the diazonium salts that we have studied even during the um, various reactions in the haloalkanes and haloarenes, which we call them as a Sandmeyer reaction. So these diazonium salts are the intermediates in the preparation of a variety of aromatic compounds, including dyes. We have seen that in the process which we call them as a coupling reaction, we have produced the dyes of orange and red color. So this is how we can easily understand that these diazonium salts are very important reactive intermediates, and they are useful for many other compounds to be produced via these diazonium salts. Now let us study in detail about the amines. Amines can be considered as derivatives of ammonia obtained by the replacement of one, two, or all the three hydrogen atoms from the ammonia by either the alkyl group or aryl group. For example, we have methanamine, that is CS3NH2, or we have aniline, that is C6H5NH2. This is alkanamine, this is arylamine. So here you can say that this is a aliphatic amine, this is aromatic amine. Same way, my dear students, we can see here N-methyl methanamine, where two hydrogens of this nitrogen has been replaced in ammonia, and then if all the three hydrogens present in ammonia are replaced by the methyl group, we get N-dimethyl methanamine. So this is how, my dear students, you can see that if the one hydrogen is replaced by alkyl group, this is here the one hydrogen is replaced by aryl group. You can see here two hydrogens have been replaced, and here three hydrogens have been replaced. So such amine, these are known as the primary amines. This is the secondary amine, whereas this is what it is called, the tertiary amine. Let us study further and understand it well. Structures of amine. Let us try to study about the structures of amine. Like ammonia, nitrogen atom of amine is trivalent and carries an unshared pair of electrons, which we also call it as a lone pair of electron. So even in amines, this lone pair, as it was present in ammonia, in all the amines, this lone pair is present. Nitrogen obtains in amine are therefore sp3 hybridized. As it was hybridized in ammonia, same way in amine also the nitrogen is sp3 hybridized, and the geometry of amine is pyramidal in shape. As it was there in ammonia, ammonia is a pyramidal shape. These amines are also pyramidal in shape. You can see this figure and understand about an amine that is of the pyramidal shape. Here we have the unshared pair of electron, and the another part we generally bind it. Here we have nitrogen um, present. So this is how, my dear students, we understand about the amines. Let's move forward and study. Each of three sp3 hybridized orbitals of nitrogen overlap with orbitals of hydrogen or carbon, depending upon the composition of the amine. So if these four orbitals are there, you can see here these four orbitals may have various kinds of here you can see that these three orbitals have overlapped with carbon of CS3, CS3 and CS3, but it may be hydrogen here, it may be hydrogen here, and only one as carbon is overlapped with one, so it is primary amine. If two are overlapped with carbon, then it is secondary amine, and if all three are overlapped with carbon, it is tertiary amine. So depending upon the structure of the amine, we can understand that what kind of overlap has been taken place by the orbital of amine with the what kind of atom. The fourth orbital of nitrogen in all amine contain an unshared pair of electrons. Due to the presence of unshared pair of electrons, the angle carbon nitrogen and E, that is your unshared pair of electron, or E that is your carbon or another hydrogen, C and E, not unshared pair of electron, but the bond angle between the carbon nitrogen and either hydrogen, or carbon nitrogen and either another carbon, is less than 109.5 degree because of the lone pair bond pair repulsion. So due to this lone pair bond pair repulsion, the bond angle decreases from 109 degree 109.5 degree. For instance, it is 108 degree in case of the trimethylamine as shown in the figure. So if we really look at the figure for the trimethylamine, we'll find that this angle, instead of 109.5 degree, it is the angle of 108 degree only. So this is how we understand the bond angle into the amines. It is always less than 109.5 degree. Now, my dear students, we want to study about the classification of amines. So amines are classified as primary amine, secondary amine, and tertiary amine, depending upon the number of hydrogen atoms replaced by the alkyl or aryl groups. Let us first study about the primary amines. If one hydrogen atom of ammonia is replaced by the alkyl or aryl group, we get RNH2 or ARNH2, which is known as the primary amine. Same way, my dear students, we can understand that secondary amine. If two hydrogen atoms of ammonia or one hydrogen atom of RNH2, that is your primary amine, are replaced by R dash or AR, we get RNHR dash, which represents your secondary amine. We get secondary amine. And then we should think about the tertiary amines. If all the three hydrogen atoms of ammonia or two hydrogen atom of primary amine or one hydrogen atom of a secondary amine is replaced by R, that is alkyl group, or aryl group, we get R3N or R2N R dash or RN R dash R double dash, and these all three can be considered as a tertiary amine. So here, my dear students, I have a representation. Suppose you have ammonia. When you remove the one hydrogen, or when you replace the one hydrogen of ammonia with R, you get RNH2, which is primary amine. Now what happens if you replace two hydrogen of ammonia or one hydrogen of RNH2, you get RRNH, that is your secondary amine. And if you replace all the three hydrogen of your ammonia or two hydrogen that is present of primary amine and one hydrogen that is present into the secondary amine by the alkyl or aryl group, you get the tertiary amine. Remember that tertiary amine does not have any hydrogen, secondary amine has one hydrogen, primary amine has two hydrogen, and ammonia has three hydrogen. So to identify what kind of amine it is, you can just look at the number of hydrogen. If in an amine there is no hydrogen present, it is tertiary amine. If in an amine, if there is only one hydrogen present, it is secondary amine. And if in amine there are two hydrogen present, it is going to be primary amine. So instead of, this is the very easy way to identify the primary, secondary and tertiary amines. You just need to look at the number of hydrogen present in the amines. If amine does not have any hydrogen, it is tertiary amine. If amine has got one hydrogen, it is secondary amine. If amine has got two hydrogen, it is primary amine. Now, my dear students, we want to study about the nomenclature of amines. We know that for nomenclature we have common system and we have the IUPAC system. So let's study about the nomenclature. In common system, an aliphatic amine is named by prefixing alkyl group to amine, that is alkanamine, as one word. Example: methylamine, ethylamine, propylamine, this way. In secondary and tertiary amines, where two or more groups are the same, the prefix di or tri is appended before the name of the alkyl group. So if you have two methyl group, we'll write dimethylamine. Three methyl group, we'll write trimethylamine. Now, what is according to the IUPAC system? In IUPAC system, primary amines are named as alkanamines, and the name is derived by the replacement of E from alkane. Remember, E from alkane, this E we just remove by the word amine. So we just write alkane, E remove an amine. So alkanamine. I hope it is very easy for you to understand that we just remove the E from alkane and then just we put the amine part into it and we just find it out as a alkanamine. So this is how, my dear students, we study about the alkanamine. You can see here the study of the alkanamines. Let's move forward. For example, my dear students, if you have CH3NH2, it is named as a methanamine. You just need to remove the E and just need to put the amine after it. In case of more than one amino group present in the different parent chain, their position is specified by giving the numbers to the carbon atom. Bearing NH2 groups and suitable prefix such as di, tri or tetra, not tetra generally because, but yes, if there are four then we should use tetra, is attached to the amines. The letter E of the suffix of the hydrocarbon part is retained. Please remember. So please have look at this. Here in the IUPAC system, this E we retain when there is more than one amine group present. So it is ethane 1, 2, this is 1 and this is 2, 1, 2 diamine. Please remember that when we write the name according to the IUPAC system, this E present into the um, hydrocarbon, we do not remove it and we write it when we have more than one amine group present into the compound. The name To name secondary and tertiary amine, we use the locant N to designate the substituents attached to the nitrogen atom. These sentences could be better understood by looking at the examples. So if you look at this CH3NH, CH2CH3, it is actually in this way. See, you have CH3 here, you have N here, and the another part is CH2, CH3. So what you do is you find out the longest chain and you combine it with the nitrogen, and then the other parts are the branches. So it is N-methyl ethanamine. You can see here N-methyl ethanamine. So just you need to combine the nitrogen with the longest chain, and then the other parts are branches, which is represented by locating them with the N. So it is N-methyl ethanamine. Now suppose you have this kind of structure where you have, this is CH3, and this is even CH3, and suppose you have CH2 and CH3 here. So you again combine it with the longest chain, and these are N. This can be represented as NN dimethyl methenamine, ethanamine, not methanamine, it is ethanamine. So this is how you understand it better. Same way, if all the three are ethyl group present, then you can write it as, suppose this is the condition that here also you have C2H5, here you have C2H5, here you have C2H5. C2H5 is CH2 CH3, so you can write it as a NN diethyl ethanamine. This is how you can do it, my dear students. Let's move forward. In aryl amines, NH2 group is directly attached to the benzene ring, that is C6H5NH2 is simplest example of aryl amine. In common name system, it is known as aniline. Remember, my dear students, that aniline is also accepted by the IUPAC nomenclature system. So even according to the IUPAC nomenclature, C6H5NH2, C6H5NH2 can also be called aniline even into the IUPAC nomenclature system. While naming the aryl amines, according to the IUPAC system, suffix E of arine is replaced by the amine. So if you really look at this, you can see generally you write benzene. So you just remove this E from the benzene, BENZENE, E you remove, and then instead of E you write amine. So this is what it is going to be, benzenamine. This is how you understand the nomenclature system. Now we have one important note to understand here. Let's have a look to the note. What does it say? Just a minute. Just a minute, my dear students. Let us read what the note says. In the following examples, we have common names is written with the green ink and IUPAC names is written with the black ink. So this is common and this is what it is going to be, IUPAC names. Let's have a look to the various names, my dear students, that we want to study. Let us look at all the names. So if you have CH3, CH2, NH2, it is commonly it is known as ethylamine, but according to the IUPAC system, it is known as ethanamine. If you have CH3, 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 CH2, CH2, NH2, common name is normal propylamine, but the IUPAC name is propane 1-amine. If you have CH3, CH3 and NH2 is on the second carbon, the common name is isopropylamine, whereas the IUPAC name is propane 2-amine. You can look at this compound where you have N-methyl ethanamine. So this is the longest chain of the carbon where you have N ethanamine. This is the portion of ethanamine, and on nitrogen the methyl group is present, so it is N-methyl ethanamine. Same way when we look at this, we have three methyl group present, so commonly we call it as a trimethylamine, but here we will write it as N dimethyl methanamine. So this is the major part, and these two are the locants that we represent with the N dimethyl methanamine. Now just have a look to this. This is ethyl group, this is ethyl group, this is the longest chain. There are four carbons, so it's a butanamine. But what kind of butanamine? N diethyl butanamine. So that is how we write the common name as well as the IUPAC name. Here, my dear students, you can see that there is a carbon chain which is made up of three carbon, and here there is a double bond present. So it is an allyl part. So we call it as a allyl amine. Please remember that in this allyl amine, the numbering is given as if this NH2 is a functional group and the carbon bonded to NH2 is considered to be the prior carbon. And this is how we can understand that amine group is prior than the alkene group. And that is why the IUPAC name is going to be prop 2 in. Remember, prop 2 in 1 amine. So please remember that this nitrogen or amine group is given priority as compared to the alkene groups. Then here, if we have a, six carbon chain, that is hexane, and on first and the sixth carbon, if two NH2 group are present, the commonly we will call it hexamethyl diamine, but according to the IUPAC system, we should call it hexane 1,6 diamine. We are already aware that benzene NH2 or C6H5NH2 is known as aniline. Even IUPAC system has accepted it as an aniline, but it can be also be written as a benzenamine. Then the common name for this compound is orthotoluidine, but IUPAC system is calling it as a 2-methyl aniline. So this is first carbon, this is second carbon. On second carbon we have methyl group and this is aniline. So it is 2-methyl aniline. Same way, my dear students, on the fourth carbon, if bromo group is present in the aryl amine, we call it as a para-bromoaniline or 4-bromoaniline or 4-bromobenzenamine. Same way, my dear students, if on nitrogen of aniline, two CH3 group are present, we call it N-N-dimethyl aniline, or we even call it N-N-dimethyl benzenamine. So, my dear students, let us examine our by solving some questions. Classify the following amines as a primary, secondary, and tertiary. My dear students, the very simple idea is you just need to look at the number of hydrogen. Number of hydrogen 2, primary amine. No hydrogen, tertiary amine. 2 hydrogen, primary amine. Very simple to understand. 1 hydrogen, secondary amine. Now, my dear students, question 1. Write the structure of different isomeric amines corresponding to the formula C4H11N. Write their IUPAC names and write all the isomers that is possible, all the type of isomers, what type of isomerism is exhibited by the different amine pairs. So let's have look to these various compounds. That is what they have the, let us first count. What is the number of carbon? 1, 2, 3, 4, and so we'll write C4. What is the number of hydrogen? Let us find out. 2 plus 3, 5 plus 3, 8 plus 3, 11. And then we have this one N. So this is the formula that we are going to study, C4H11 In this C4H11 my dear students, the first compound which we have is arranged in this, and the name IUPAC name is 2-methyl propanamine, propan 2 amine. You can see that with nitrogen we have 2 hydrogen, so it's a primary amine. The second one is the N-methyl propan 1 amine. You can see here this is the propanamine part, and then you have first, second, and third carbon, and then you have CH3 bonded to it, so it's a N-methyl propanamine. As nitrogen is having one hydrogen, it is the secondary amine. Same way, my dear students, on both the side we can have the same kind of chain, and that is N-ethyl ethanamine. You can see here only one hydrogen is present, so it is the secondary amine. And as there is no hydrogen present, it is the tertiary amine, which we call it as a N-dimethyl ethanamine. Now, my dear students, if we really want to study about the various isomers that they can form, we can easily look into this. The chain isomers are 1 and 3. These 1 and 3 are the chain isomers. I think we have not seen few of the others isomers. The first isomer is here. Let us look at this. The first isomer is a normal isomer where you have all the four carbon in the same line, and that is what it is known as the butane 1 amine. Suppose this nitrogen or this amine group is present on second carbon, that is going to be the second butane 2 amine. Then you can have the isobutyl chain where one CS3 is not in the same line, but it is present into the branch, which we call it 2-methyl propane 1 amine. Again, there are two hydrogen present, and that is why we call it as a primary amine. So my dear students, the chain isomers are 1 and 3. These 1 and 3 are the chain isomers. Then let's have a look to the other isomers that we need to study about. Then 2 and 4th, you can see that this is the second number. This is this 2 and the 4 number uh, compound. This is the fourth one. These two are the chain isomers because they have different arrangement of carbon. And 1 and 4th, this first one, that is the normal one, this first one and this fourth one are uh, also the chain isomers. We can call them as a normal, iso and neo. So according to the arrangement of the carbon, these normal, iso and neo are the chain isomers of each others. Then when we look at the position isomers, the first and second, because first one is one amine and second is a two amine. Same way one and fourth. So first one is one amine and fourth one is two amine again. You can see here it is two amine, and that is why they can be considered as a position isomers. And then my dear students, we have metamers, that is 5 and 6 and 6 and 7. These are the metamers of each others. You can see these compounds, they have various different arrangements around this nitrogen. So around this nitrogen, there are various groups are present, and that is why these three are either the considers of the metamers of each other. So this is how, my dear students, we can easily study about the nomenclature and isomerism. In the next period, we should study about the preparation of amines. So today we have studied about the various uses of the amines. The amines are majorly used into the preparation of the polymers and drugs and dyes. Majorly, they are very good intermediates. We have studied about the diazonium salts, and they are very good intermediates. Then we have studied about the bond angle, that generally the bond angle in amine is less than 109 degree 28 minutes or 109.5 degree. And then we have studied the classification. We have seen that the amines can be primary, secondary, and tertiary amines. And depending upon the number of hydrogen, we can easily identify the primary, secondary, and tertiary amines. Then we have studied about their nomenclature, and then we have studied about their isomerism. We can see that these amines can show the chain isomerism, they can show the position isomerism, and they even show the metamerism. So this is how, my dear students, today we end up the class. I hope you have enjoyed the class. Wish you happy learning.